So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamualaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So we were discussing section 3 waves, and today we are going to start section 3.2, that is light. The law of reflection of light states that angle of incidence for a ray of light is always equal to the angle of reflection, that is denoted by R. The angle of the wave approaching the boundary is called the angle of incidence, whereas the angle of wave leaving the boundary is called the angle of reflection. The line at right angle to the boundary or to the mirror or to the surface is known as normal. This line, see, this is a plane mirror, this is a torch producing a light wave or a light ray. The line in the middle at the right angle to the surface is known as normal, whereas the angle between normal and the source of light or the coming wave is known as the angle of incidence, whereas after the light ray is reflected, the angle between the reflected ray and the normal is known as angle of reflection. Reflection in a plane mirror. When an object is placed in front of a mirror, an image of that object can be seen in the mirror. Always remember that in a plane mirror, the image will be the same size as the object. It will be at the same distance behind the mirror as the object in front of it. The image is directly in line with the object. The image and the object will be in the same plane. The formation of this image can be understood by drawing a ray diagram. Light from the object hits the mirror, reflecting from it as per the law of reflection of light. To an observer, the reflected ray appears to have come from the right hand side of the mirror. The reflected ray can then be traced back in this direction, forming a virtual ray. This can be separated for another ray traveling in a slightly different direction. An image of the object will appear where these two virtual rays cross. The type of image that is formed is called a virtual image. A virtual image is formed by the divergence of rays from the image and cannot be projected onto a piece of paper because the rays don't actually go through the image. Over here, let's try to understand these points. This is a plane mirror, this is a flat surface, and this is an object. Now how you see this object is that the rays from the top and bottom of this object falls onto the mirror and then they are reflected towards the eye. Now the eye, where exactly would the object be placed? The eye sees this object at the point at which these two rays strike the mirror. You'll have to extend them, forming virtual rays. When these objects, rays are extended in form of virtual rays, then the point at which these two rays fall, at that point the virtual image will be formed. And remember that the distance between the mirror and the object will always be equal to the distance between the mirror and the virtual image. So if you're given a plane mirror and you're asked to draw the position of the image, always follow these points, these rules. Simply extrapolate the lines between the eye and the object, extrapolate them in form of dotted lines, and when you have reached the same distance that is between the mirror and the object, at that point just form the image of the object. Refraction of light. Refraction occurs when light passes a boundary between two different transparent media. At the boundary, the ray of light undergoes a change in direction. The direction is taken as the angle from a hypothetical line called the normal, which is perpendicular to the media, to the surface of the boundary. The change in direction depends on which media the light ray passes between. From less dense to more dense, for example, when entering from air to glass, light bends towards the normal, whereas if the light is moving from denser media into a less dense media, for example from glass to air, the light bends away from the normal. Remember these two rules in order to tackle any question that would come for the refraction of light. When passing along the normal, the light does not bend at all. The change in direction occurs due to the change in speed when traveling in different substances. When light passes into a denser substance, the rays will slow down, whereas when light passes from a dense material to less dense material, its speed will pick up, hence it will bend away from the normal. Here is a diagram to make you understand. This is air, and when light ray strikes this glass block, at that point we'll draw this imaginary line that would be the normal. And as you can see, since it comes from a less dense medium into a more dense medium, solids are more dense, it bends towards the normal. This angle of reflection, in fact angle of refraction, this angle between normal and the ray is less than this angle because it has bent towards the normal. Whereas after a while, when it hits the corner, the edge or the boundary of the glass block, and it is again going outside into air, then as you can see, this angle is greater than this angle because the ray has bent away from the normal. Refractive index. The refractive index is a number which relates to the speed of light in the material, and we have a formula for that. N equals to sine I upon sine R. Now what is I? I is supposed to be the angle of incidence, whereas R is supposed to be the angle of reflection. The refractive index is a number that is always larger than 1, and it is different for different material. Objects which are more optically dense have a higher refractive index. N is about 2.4 for diamond, whereas objects which are less dense, they usually have a lower refractive index. For example, a glass is about 1.5. Since refractive index is a ratio, it has no units, but you need to remember this formula. It is very important for calculations in paper 2 and paper 4. n equals to sin I upon sin x, sin r, sorry, not x, sin r. Next we have something that is known as total internal reflection. Sometimes when light is moving from a denser medium towards a less dense medium, instead of being refracted, all of the light is reflected back into the medium. This phenomena is called total internal reflection. It occurs when the angle of incidence is greater than the critical angle and the incident material is denser than the second material. Therefore, the two conditions for total internal reflections are that angle of incidence should be greater than critical angle. What is critical angle? We'll discuss in a while. The incident material is denser than the second material, means light must be going from a denser material into a less dense material. If light is coming from a less dense material into a denser material, total internal reflection will not take place. So normally total internal reflection, TIR for short, usually only occurs in solids. This is an image. For example, over here critical angle is supposed to be 48.8 degrees. Now the ray of light which was at 90 degrees, means at normal it does not bend at all, whereas the ray of light which was less than 48.8 degrees or at 48.8 degrees, all of these rays of light have bent away from the normal. As you can see, the incidence angles are lower, whereas the reflected angles are greater. But in this case, when the incidence angle was greater than the critical angle, all of the light has reflected internally inside the same medium, instead of some of it being refracted outside in the air. This is known as total internal reflection, when all of the light ray is reflected back into the medium. Critical angle and total internal reflection. Total internal reflection is utilized in optical fibers, prisms, for example periscopes. Prisms are used in a variety of optical instruments, for example periscopes, binoculars, telescopes and cameras, etc. What is a critical angle? This is the angle of, as the angle of incidence is increased, the angle of refraction also increases until it gets closer to 90. When the angle of refraction is exactly 90, the light is reflected along the boundary of the object. As you can see, when the refracted angle became 90, the light ray traveled along the boundary of the water surface. At this point, the angle of incidence is known as the critical angle C. So the point at which the refracted angle becomes 90 degrees means light ray travels parallel to the surface of the or the edge of the medium. Then in such a case, the incident angle of the light ray is known as the critical angle. This is denoted by small c. Refractive index and critical angle. The relationship between the two quantities is given by the scenario n equals to 1 upon sin c. Again, this is another important formula that you need to remember. The equation shows that the larger the refractive index, the smaller the critical angle. So objects which are more dense will have a smaller critical angle. Light rays inside a material with a high refractive index are more likely to be totally internally reflected. Here is an image of an optical fiber that shows how light rays are internally reflected and light is able to travel inside the fiber optic for a very long distance. Optical fibers can be used by doctors as an endoscope, by engineers to light up some awkward spot for inspection. They are used to carry telephone, internet and cable TV signals as well, in form of pulse of visible or infrared light. They can also be used over very long distances. The cables are unaffected by electronic interference as data is traveling in form of light. They are made up of cheap material as glass is cheaper than copper or other metals. They are easier to handle and install. They are not but the drawback is that they are not as strong as copper cables, and they can break if they are bent too much. The diagram shows two divergent rays of light from an object O being reflected from a plane mirror. Now you have to find out at which position the image is formed. This is the mirror. You simply have to extrapolate both these lines. This line is straight, so we'll simply extrapolate it like this. This line is curved, so when we virtually extend it, it will go meet at B. Okay, I'll simply draw it for you. See, this is a straight line, so that means its virtual image, its virtual array or virtual line will also go in straight. I think this might be now. This is at around 45 degrees angle. We have to extrapolate it in the same direction. As you can see, these both lines are meeting around B, so hence B would be our answer, that at point B our image would be formed. Which statement is correct? Total internal reflection only occurs when light travels from air into glass. No, because in this case light is traveling from less dense to denser material, whereas we have studied it occurs when the opposite is happening. The larger the refractive index, the larger is the critical angle. No, that is wrong. We have studied that the larger the refractive index, the smaller the critical angle. When total internal reflection occurs, the angle of incidence is equal to the angle of reflection. No, that is false. When it occurs, sorry, yeah, that is true. That is true. When total internal reflection occurs, both angles become equal. When total internal reflection occurs, the angle of incidence is less than critical angle. That is wrong. It is greater than critical angle, otherwise total internal reflection would not occur. Hence statement A, B and D is wrong, whereas the C is the only correct one, so our answer would be C. Okay. So this is it for today's lecture. I hope you have understood everything. Feel free to contact me if you have any issues. Please do give your comments, and I'll see you guys in the next lecture, and we'll discuss lenses. Take care. Allah Hafiz.